This module examines the concept of forecasting and its use in budgeting. In this module, we'll define what is a forecast, how to prepare data for use in forecasting, walk through several basic forecasting techniques, and end with how to evaluate the results. A forecast helps to predict the continuing budget baseline and helps to estimate the impact of changes. Forecasting is essential to budgeting and long-term planning. Even a new organization has to make estimates about its income and expenses for the next year. So too must a more mature organization that has years of experience in delivering services. A good forecast reduces uncertainty but will not eliminate it. Rather, compiling and analyzing data can provide managers with the tools to assess where there are financial risks that should be addressed in more detail. For example, forecasting future collections of a fee for testing services might reveal that the real inquiry should focus on why the number of clients served keeps falling and why there is a rising rate of non-payment of charges. The fact is, the more you know about what drives each budget element, the better you can predict their future values. Forecasts are about measuring accuracy. A forecast is only as good as it is accurate. Having said that, there is still value in an inaccurate forecast because it requires you to look more closely at what went wrong. That search process often yields better insights for use in the next forecast. You can always learn from past mistakes. Forecasting is only as good as the data used. Revenues and expenditures need to be looked at separately. It's best to look at each line item, but some of the smaller, less important items might be grouped together to simplify the task. What drives each line item revenue source? If there have been rate increases or changes in target groups, then the historical data series cannot be taken at face value. The rate increase may have increased revenues because the same number of clients paid more per visit. It's also possible that revenues may have decreased because the price increase was too high for some to pay, thus decreasing the number of clients. It's critical, therefore, to look at the historical data series in relation to changes in the underlying nature of the service and client environment. Also, be sure to identify any one-time or unusual items in the data series in order to assess if they might reoccur. Otherwise, it makes sense to go ahead and adjust the time series to minimize the influence of that one-time or unusual event. In other words, remove it. Needless to say, a clean data set is needed that takes into consideration the factors that drove the numbers. When we talk about clean, it means the data is complete, accurate, and has been adjusted for any unusual one-time occurrences. The goal is to understand each revenue and expenditure line item as best possible. Only then can a good forecast result. Budget forecasts are built on the history of each revenue and expenditure line item. But you also need to know client service history. What is the history of the number of clients served by various types of services performed? And what changes have occurred in the fees charged, or in the practices used in collecting past due amounts, or even in variations in service delivery methods? Perhaps there was a change in protocol to a single nurse giving 2 shots rather than having 2 different nurses giving 1 shot each. This service delivery change could impact the number of customers served, the labor costs for the nurses, and other features. Knowing, or more likely just remembering, these changes may help explain the pattern of the historical data series. There are external factors that influence local budgets. National macroeconomic variables such as interest rates, unemployment rates, and currency exchange rates can greatly influence your budget. The growth or decline of the general population, or more likely the target groups, can affect the number of clients served and therefore collections and costs. Obviously, the incidence of HIV impacts the work of a clinic devoted to HIV treatment. Local poverty makes it hard for individuals to pay for services. Public health indicators such as disease risks and outbreak projections will impact a health clinic and its budget forecast. This slide offers some links to sources of macroeconomic factors in Tanzania that might be used in the development of a forecast. It cannot be emphasized too much. Always document your work through detailed notes. These notes will become a useful tool when you need to forecast budget data in future years. Record all changes to the historical data series, especially any changes to deal with the unusual or one-time events that you had to smooth out of the data to produce a clean data series. Be consistent in the use of a fiscal year or a calendar year in recording the data. Document the forecast methodology used and why, even providing notations on why other methods were found not to be useful. All of this is to say that you want to document what you do so that you, or someone else, can recreate your work at a later period. Besides, we all forget things, so it's best to write it down. There are numerous techniques to use in forecasting, from the most naive to the very complicated. There's no best way, it simply depends. Let's look at some of the factors to consider. Accuracy is important, but there's no one method that assures accuracy of results. It might help to try different techniques to see which ones would have best forecasted past results using past data. That might give you more comfort going forward, assuming the past is the best predictor for the future. Using techniques that take too much time because you have to wait for information from some distant source, or a time-consuming search of archival records, may not be useful for small staff working on a time-sensitive budget process. There are some macroeconomic data sources that may be very beneficial, but cost too much money to rent or buy. You may have to go ahead without them. In what we do, mechanical forecasting is not likely to replace a human's judgment anytime soon. An Excel spreadsheet by itself can't answer the question, is that revenue assumption reasonable given what we know about the local community or the grant program? It takes a manager knowledgeable about the context of local health services. How would a spreadsheet interpret the local impact of decisions by higher levels of government or broader economic or demographic trends? Only you can do that, using your best judgment. Getting it right can save money. Correctly forecasting the amount of money to be received from the central government, donors, or paying customers will allow you to plan your workforce and resource use more effectively. That will save money, reducing the inclination to overstaff or purchase too much inventory. All of these factors point to the importance of having a skilled budget forecaster. Otherwise, mistakes can compound and make budget life difficult for the entire year. Now, what do you do when you apply different forecasting techniques, but each one produces a different result? A common rule to apply when two approaches are equally reliable is to go with the simplest technique. More sophisticated forecasting techniques do not necessarily lead to more confidence in the forecast results. The first group of forecasting techniques are very practical and not technical. The naive approach uses last year's value and moves it forward. No new information is added. Some might say it's a conservative forecast because it assumes what happened last year will be repeated. That may work if nothing is changed. In the judgmental approach, typically, something changed other than time. Last year may have been a great year unlike those before. Maybe it's best not to expect another great year. So you use your judgment and estimate a lower budget. A third, non-statistical approach is to use a group forecasting exercise. You invite in a group of experts and have them try to come to a consensus. Who might you invite for the small group? You might convene a group of managers from other laboratories to discuss their projections of future services. Or it could be more high level and include economists, health experts, epidemiologists, business leaders, or others. The number and their background would vary by the nature of the forecast expected. Short of a consensus, you at least end up with a basis upon which to step out with your own forecast. A simple method is to use what's called a deterministic formula. That's one where you know the future value of the items that are multiplied together. Several examples help illustrate this point. The tax rate times the tax base equals the tax bill. The number of clients times the fee charged equals the income earned. The number of shots given times the cost per shot equals the cost for shots given. All of these produce results if you know or can estimate the multiplicand. There are a series of methods that are termed time series methods. The name comes from having past behavior predicting the future, with time as the key change. It's best to keep in mind several key assumptions in the use of time series forecasting methods. This group of techniques assumes that the past will persist into the future and that any changes in the data recur regularly and will continue into the future as well. The data itself must be valid, that is, it accurately describes the real situation. And the data must be reliable, in that others could replicate the results if they use the same data and technique. As we mentioned earlier, you need to have a clean and consistent time series of data that has been cleaned of changes, such as an increase of fees that could mask the reason for an increase of revenue instead of it being the result of more people getting the service. A fundamental problem with the time series method is that it cannot detect a turning point. It's similar to walking in a straight line and expecting to continue, but coming up to someone who just stepped into that spot, making you turn away at the last second. A time series cannot detect that new obstacle. As you work on the various forecasting methods, remember that they can work for monetary units, as in the budget, as well as number counts, such as inventory count or customer counts. Constant change is one method that relies on a trend. Say you have 2 months of data, 190 last month and 200 this month. You want to forecast the next month. You can take the percentage change by dividing the newest number, 200, by the oldest number, 190, then subtract 1, and convert it to a percentage by multiplying by 100. The result is a change of 5.26%. Now, take that change rate of 5.26% and multiply it by the current month of 200 to get 10.52, and add it to the 200 to get the forecast for the next month of 210.52. Another time series method is a moving average. The goal is to smooth the trend line out of the ups and downs of yearly percentage change. A 2-month moving average is shown, but it could be 3 months, 10 months, 30 months, or any number depending upon the length of the time series and the value gained by smoothing it over a longer period. To get to the May forecast using a 2-month moving average, you only need to look at the March and April numbers of 107 and 104. Add them together and divide by 2 to get an average of 105.50. This is your May forecast. A weighted moving average says that the equal weights used in the prior method is not as valuable as assigning different weights to the prior periods. Perhaps you consider April's results to be more indicative of what May will bring, so you give April a 40% weight, while assigning a 30% weight to March, a 20% weight to February, and only a 10% weight to January. Of course, these are just hypothetical weights in this example. To come up with the weights you want to use, you'd need to know more about your data series and what's been driving the monthly results. Weights are usually selected based upon experience and judgment. Although it does not have to be this way, usually the more recent period gets the highest weight, and all weights should add up to 100%. Another time series method is to compute the compound annual growth rate for the time series, and then use that rate to make a forecast. Suppose we had a series with 4 annual amounts, and we wanted to forecast the next 2 years. First, we compute the compound annual growth rate. The factors we use are the oldest number of 100 and the most recent number of 104. There are three changes, from year A to B, from year B to C, and from year C to D. A common mistake is to assign 4 because that is the number of time points. But we're not concerned with time points, but rather changes, so it's only 3 changes. The formula we use is 104 divided by 100. It's then raised to 1 divided by n power, n being the number of changes, or in this case 1 divided by 3, and then minus 1 from that result. You then multiply the result by 100 to convert it to a percentage. The result is that, in this example, the compound annual growth rate is 1.32%, from 100 in year A to 104 in year D. We can now use that 1.32% compounding rate as an input to the compound interest rate formula, which is the present value times 1 plus the rate raised to the n power. To determine the forecasted future value for 1 year out, or year E, we plug in the numbers. The present value for year D is 104 times 1 plus the compound interest rate we just calculated, which is 1.32%, or restated as 0.0132 raised to the n of 1, produces the forecast of 105.37 for year E. If we want to project out further, we can use the same inputs but raise it to the power of 2 to produce a forecast for 2 periods out, or through year F, of 106.76. Let me try to demystify something here. We use the wording of raising to the power of. What does that mean? It's a mathematical operation called exponentiation. The n means the repeated multiplication of the base number. So, in doing the future value calculation, you add 1 to 0.0132, then multiply by 104, and then raise to the power of 1 over n. That means that you take the product of 104 divided by 100, or 1.04 times 1.0132 times 1, to finally get 105.3728. For the second year out, it is 1 plus 0.0132, or 1.0132 times itself, to get 1.026574. Then times 104 to get 106.7637. What if you have a forecast total of 1,100 for the next year but want to divide it into quarters? The simplest approach is to just divide by 4 to get the average quarterly amount of 275. But there may be seasonal differences that you should take into account. Seasonal differences in service delivery may be something like spikes in clients visiting during certain times of the year. Maybe harvest is over, so they have more time to travel to the nearest clinic to receive services. The solution to dealing with seasonal differences is to divide the prior year's quarterly amount, say the 200 in the spring quarter, by the actual total for the current year, or 1,000, to produce a seasonal factor of 0.8. This means that the spring quarter is 80% of the yearly average. You would multiply that 0.8 by the forecast average of 275 to get a new seasonally adjusted spring forecast of 220. Simply continue that process to adjust your next year's forecast for the remaining 3 seasons of summer, fall, and winter. Of course, you can use the same method not just for quarters of a year, but also for monthly periods, or for some other frequency that you think is important to use in forecasting, which also needs to address seasonal differences. The prior methods were all based on a continuation of trend lines with only a change of time. There are many other methods, but they rely on sophisticated modeling. Such models are built on a theory of linkages between multiple variables, such as economic, demographic, or sociological characteristics, that cause a particular dependent variable such as revenues. Regression analysis is the cornerstone of causal modeling, but that discussion is a topic beyond the scope of the current module. This slide illustrates the complicated nature of causal modeling, such as predicting the HIV prevalence rate. Various socio-economic variables, such as the economy and population, represent environmental influences. Additionally, there are numerous socio-cultural value variables, such as risky behavior, that indicate behaviors of influence. All of these impact epidemiological variables that predict HIV prevalence rates. Larger and more complicated organizations conduct causal modeling to fine-tune their forecasts. Budgets are built on forecasts and estimates, so the real value derives from the accuracy of the results. There are ethical issues to consider, though. It's not appropriate to intentionally underestimate revenues as a means of creating an expected end-of-year surplus or an emergency savings fund. Underestimating the spending is just as bad as overestimating it. In government, it's not ethical for an unelected forecaster to limit the policy options of elected officials. Rather, give elected officials and managers the assumptions and caveats used to make the forecast, and even tell them the confidence that you have in the forecast, so that they can then make the final decision on what forecast to use. As in most things, we can learn from our mistakes. The goal is to improve our forecasting ability over time.